that. Okay. All right, I think it's working. Okay. And let's hit done here. Let me check one more thing. Let me go ahead and let this student in. Hold on. Move on there. And got this one. Let me hit save. Okay. So right there. Okay. And one more thing. Check one more time. That looks good. And I'm going to go ahead and share my screen. Start the broadcast. Okay, we'll start off here. All right. I think that's fine. You see? Yeah, cool. All right, so welcome, gentlemen. This is the top of week 5. We're almost at the halfway mark. Like, this stuff is going to be over in the blink of an eye. It's going to be over very, very quickly, right? Very quickly. Anyway, it's going to be over quickly. I paused because I saw something that was like, don't ever use the word very. Like, if you say you're very hungry, just say I'm starving, or very is like redundant. There are so many words that mean very. Anyway, so that's why I paused. Anyway. Okay, so we are at the top of week 5, right? So what that means is we only have 2 more sections left in chapter 2, right? And then exactly 7 days from right now, exam 1 will become available, right? So usually for the week of exams, we only have 2 more sections in chapter 2, it's 2.5 and 2.6. I know 2.6 is really short, right? So what we're going to do today is just do section 2.5, and then on Wednesday we'll do just section 2.6. Again, my intent of this time during class time is really for it to be a Q&A. I just go through as many homework questions as I can, because trying to get students to talk sometimes is like pulling teeth, right? So feel free to stop me. We can talk about anything. I didn't load the lecture for sections 2.5 and 2.6 until like the wee hours of this morning. It was like 2 or 3 in the morning, something like that. I was like, okay, let me go ahead and load these lectures for the week before, because I'm king of procrastination. So with my exams now, as a warning, or just a heads up, warning is the wrong connotation, but I'm under the impression that I made prerequisites for the exam in the form of at least 50% on the corresponding quizzes, right? So if this is week 5, I think we have a total of 5 quizzes that we've been responsible for. So in order to access the exam, I'm under the impression that, here, matter of fact, instead of being under the impression, let's just pull it up. So let's go here. Come on, this one, I want to go back to the previous page. Yes, right here, right? Let's see. Quiz week 5. Oh, you can't see it. Okay, so I'm gonna give you a little bit of, I'm gonna allow you to see what I see. It's a little bit. Okay. So now, if I scroll down to week 6, right? You see exam 1 there. You can't see it yet. It's gonna become available Valentine's Day, right, at 6 p.m. at the start of class, so a week from today. It'll be available for 7 days. Let me see, can I see the prerequisites? Settings for the class. It should have prerequisites. Chapter association. Prereqs, yeah. So weeks, yeah. So the prereqs are 50% on the corresponding quizzes, right? So for quizzes 1, 2, 3, 4, and 5, you have to score at least 50% in order on those assignments in order to access the quiz. But I think for each quiz, I made a prereq that you got to score at least 50% on the corresponding homework. So if you're not caught up on your homework, you definitely want to go ahead and get caught up on your homework, because you don't want that exam to become available, and you only have 7 days. I know it seems like you got plenty of time, but 7 days is gonna go by quickly, and you don't know how much time you're gonna need to get this exam in order, right? Just like with all of our assignments, we get unlimited attempts. The system is set to take a higher score. Even though the due date is like 7 days later, you can still work on any assignment past the due date with a 10% late penalty. Okay, I think those are the pertinent items that we needed to talk about regarding the exam. Also, feel free, like if anything isn't clear, if you have questions about anything, feel free to unmute yourself and we can talk about it. We are live streaming on YouTube, and let me check my attendance really quickly. Okay, let me get the student before I forget them. Oh, edit. It was this student. If you're just joining us, I've already done the announcements, so I would say you're just gonna have to check the recording to see what I said, but it was regarding exam 1 that's coming up a week from today. Let me hit record. This we want today. So again, so we have 2 sections remaining in preparation for exam 1, which is the last 2 sections of chapter 2, which is 2.5 and 2.6. And again, my intent for this time period is to be a Q&A, but I just go through as many homework questions as I can because it's kind of difficult to get students to speak up. So what we're gonna do, we're gonna go ahead and hop over to Pearson and take a look at the questions associated with section 2.5. Now, again, we can talk about a different assignment or different questions. Let me see, this is an augmented review, so I'm gonna hop straight to something that comes from section 2.5. So this is all review stuff. Section 1.5, there's something from 2. This is a problem solving for 2.5. Okay. So now let's see. So this question says, it says a chemical substance has a decay rate of 6.7% per day, right? This is what applications of exponential decay. Okay. It says the rate of change of an amount n of a chemical after t days is given by this. So the rate of change is going to be a negative 0.067 times the original function, right? So that capital N is the original function. Let me see. Or the amount n, right? So let n not represent the amount of the substance present in time equals 0. Find the exponential function that models the decay. Suppose that 400 grams of substance is present at this. Okay, let me do the following, like this. I want to get a copy of this. Okay. So let's give this a go. I'm gonna give it a go. I might have to. Let's just do it. Let's give it a go, and then depending on how we do, we'll adjust in the fly. And I'll try to make this as simple as I can. Sometimes I do tend to. I can overthink these, so I'll try. Yes, I could for it to be visible. All right. Let's see. Okay. So it says a chemical substance has a decay rate of 6.7% per day. Okay. It says the rate of change of an amount n of the chemical after t days is given by this. All right. That's fine. So let n not represent the amount of the substance present at time equals 0. Find the exponential function that models the decay. Okay, we could. So there's 2 functions to choose from, but I'll try to keep it simple and just focus on one, right? So we'll just use the exponential model, and we just got to put it in context. It might. Let's just kind of try it. Okay, so exponential decay. We're gonna say it's kind of like PERT, right? N equals n naught e to the, what's our r? Where is it? I'm gonna just say KT, right? It's like PERT, PE to the RT. So it says let n not represent the amount of substance present when time is 0. Find the exponential function that models the decay. So let's see what other pieces of information were we given? Let's see what else. It says the chemical substance has a decay rate. So that means that our K, the decay rate is 6.7% per day. So let's just write it at 6.7% for right now. It says the rate of change, that's fine. Okay. Let's see, how can we use that? Okay, I think that's that. Okay, that's fine. So let n not represent the amount of substance at time equals 0. Find the exponential function that models the decay. Let me think about it. Let n not represent the amount of substance when time is 0. So if we let the time be 0, yeah, we need something else. Find the exponential function that models the decay. So then if we take the derivative here, does that help us? Okay, how much remain after 6 days? Oh, you know what? I remember. So with this one, let me see, can we use that K? So if we take the derivative, that'll be what, this times the original t. That's fine. Okay, so the only thing I can see with what's given is this. So the amount is going to be basically whatever we start with times e, and then the rate is, you got to express that rate as a decimal, 0.067 times the time, right? And it seems like they're going to give us these other pieces of information. I was looking for like more information to go ahead and solve for n naught, but I think we just leave it, right? So based on whatever we start with, then this basically I just plugged in the rate. That was the only thing I was given. That was the only thing I plugged in. Before I submit that, what I'm going to do is look at Pearson and just make sure that it has like a, no, I don't want to stop. Make sure that it has a similar form before I submit it, right? So what I'll do, I'll hop back over here. I'm going to click on View an Example, and it should still have the n naught in there for part A, right? Okay, notice this is a blah, blah, blah. So we got that, we got the rate. Okay, and then the other thing is that they're using the exponential decay formula, right? So that's fine, we'll use that. That's part B, right? So the only change that we need to make is we need to just use exponential decay. So what we have is fine, we just need to use a negative exponent. So then for hours, and let me go ahead and make this adjustment over here. So this is like exponential growth. Since we're doing decay, we're just gonna put a negative here, and we need a negative here because we're talking about exponential decay. So then otherwise everything else was fine. And then what we're gonna do is hop here. Okay. So n of t is gonna be n, nope. How do I get the subscript? Is that that one? There it is. N naught e to the negative to the power of, and again, all we did was we took the exponential decay formula and all we did was plug in the rate. And we're just leaving the initial amount open because I think they're going to give that to us later. 0.067 t. Okay. Let's try that one. Okay. And then for part B, now we're giving some information. Let's hop back over here. So then this is like this, like that, style here. Okay. So then that was part A. So then part B, it says, suppose that 400 grams of substance is present when time is 0. So when the time is 0, we have 400 grams. How much will remain after 6 days? So then we want to find, we're basically asked to solve for n of 6. That's after 6 days. Okay. All right. So then the amount present after 6 days is going to be, we're starting with 400 grams, e to the negative 0.067, and our t is going to be 6 days, right? So we're just going to crunch that number. So then, let's see, we want this guy. Can we just, we want it separate? Nope. I don't know. Cancel. How do I cancel this? I don't even know what it's doing. I don't want to say. Come on. Let's drag it here. And then I can bring this back. I was trying to avoid all this as well, but that's okay. Okay. So yeah, we just want to, oh no. Come on. All right. So we want to crunch this number. Okay. Let me finish this one and then asked the question at the end because we're almost there. We passed the hardest part, I think. E to the power of negative 0.067 times 6. Okay. Okay. So if we started with 400, we finished with 267. I'm going to do 0.5923, right? I know that's probably further than what they asked for. Let's see. So we get that this is approximately 267 point, I'm going to do 5923 grams remains. This thing does not sound stable. This is what I want. Let's copy. Let me at least submit this one and then we can pause for it. Questions. So then here, come on. No, I didn't. I know where it is. It's here. Yeah, there it is. Okay. Yeah, that's what I want. Okay. So then for part B, it says round to the nearest whole number, right? So the nearest whole number is going to be 268. 268. Okay. Did someone, if you have a question now, is a good time. You know, if you have a question, let me check my attendance really quickly. Okay, let me get the student. Okay, admin, save. Okay. Let's see right here. No, I think we're done there. Okay. So then after 6 days, the rate of change, so basically they give us the rate of change, or you could take the derivative, right? But they give it to us. So it says, what is the rate of change of the substance after 6 days? So you see the rate of change kind of in the upper right-hand corner there. Even if you took the derivative, you should still get the same thing, right? So then here, let's go ahead and take the derivative. So if we have n of t, we have that, no, that's not an n. N of t equals n naught e to the negative 0.067 t, right? So then d by dt, or the derivative of n of t, right? So, and actually this is after 6 days. Let's see, so n naught is just a constant. These still have the same conditions? Okay, let's I think we still start with 400, right? So the 400 is just going to persist. So remember, I think we said that the derivative of e is itself, right? So we're going to have e to the negative 0.067 t times the derivative of the exponent. Again, the derivative of e is itself times the derivative of the exponent. So we got to say times this negative 0.067, right? And you see that in the upper right-hand corner, dn by dt right here. dn by dt equals negative 0.067 times n being the original function. All right. Okay, you see it. Negative 0.067 times the original function. Okay. And I think our t here is 6. So I'm going to change this guy to 6. Okay. So then really all we have to do is take that negative 0.067 times our previous answer. Right. So then this is going to be approximately, all we have to do is say the negative 0.067 times the previous answer. So then first, let's go here. Oh, here, I could do this. Cool. Okay, that's what I'm looking for. Let's see. So we got that 267. So I'm going to say that answer times negative 0.067. Okay. How much remains, or what's the rate of change? So it's losing like at 6 days, it's losing about 18 grams per day. Let's see. How do they want the answer? Round to 1 decimal place. So negative 17.9. Let me see. Negative 17.9, all right? Negative 17.9 grams per day. Let's see. Okay. And let's make that note here. Nope. This one. Paste. Okay. Let's try. We got one more part. And again, you get more comfortable with this the more you do it, right? I know it seems a little bit choppy, but the more you do it, it'll become second nature, and it's not as bad as it seems. And in part D says, after how many days will half of the original, the half-life, right? It says, after how many days will half of the original 400 grams of the substance remain? So we talked about half-life. The way I remember half-life is like KT equals the natural log of 2, right? If you want the backstory on it, we can talk about that, but this is essentially the half-life formula. So where K is the decay rate and T is the half-life, or how long it takes for half of the substance to remain. So then part D says, after how many days, so we're solving for T, will half of the original 400 grams remain? So then the K, okay. So we use the K. So let's see. So then the half-life is going to be the natural log of 2 over K, and that's going to be the natural log of 2 over this negative 0. Let me think about it. I don't think we need the negative. Yeah, let's just lose the negative. 0.067, right? Yeah. So then if we said the natural log of 2 divided by 0.067 after, approximately after about 10 days. 10 point, I'm going to, let's do 3455. And I think these are days. Where everybody knows your name. Boom, 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 boom. All right, and let's try it out here. Not that one. Yeah. Whew. I got nervous. I lost it. Okay. Half of the substance will remain after it says round to 1 decimal place. So that's going to be 0.3. 10.3 days. 10.3. Okay. I feel like there should be questions. I understand if you don't ask them. Let's just try another one, right? We're just gonna keep working through examples. We might even come back to this, do more of this on Wednesday. It just depends on our time. Let's see, substance, and let's go like this. I think that's good, actually. Okay. Let's see. So it says substance A decomposes at a rate proportional to the amount A present. Write an equation that gives the amount A left of an initial amount A naught after time T. Let's see, substance A decomposes. Write an equation that gives the amount A left. So it just sounds like exponential decay. Exponential decay takes on the form of A, right? It's like PERT with a negative exponent. And the only one that's close to PERT is the A and D, but A is exponential decay and D is exponential growth. So I am just going to go with A. That's the only one that has the proper form. And then, okay, so there will be 1 pound left after how many hours? Okay. It is found that 14 pounds of A will reduce to 7 pounds in 3.8 hours. After how long will there only be 1 pound left? Okay, so let's put these two pieces of information together right here as well. Okay, come on. So I'll take it from here. Actually, all I need is like this part. Okay. Okay. So again, we're using exponential decay. Let's see, I think we had A of t equals A naught e to the negative kt. Okay. So then for part B, that was part A. Part B, let me see. We'll reduce to 7 pounds and okay, so it says that 14 pounds of A. So that 14 pounds is our A naught. So they're telling us that A naught is 14 pounds. We'll reduce to 7 pounds. So that's like the half-life, right? So we can say, I'm gonna use capital T for the, or which is our half-life. It takes 3.8 hours. After how long will there be one pound, right? Okay. So the half-life formula, if we're using half-life, let's just go ahead and call on the half-life formula. That's what, I use it as KT equals the natural log of 2. They gave us the time for half of it to remain, so this we can get the rate from here, right? So the only piece of information that we don't know from half-life is the rate. So we can solve for that. So then the rate is going to be the natural log of 2 over the half-life, and that's going to be the natural log of 2 over 3.8, what is that, hours? Yeah, right? So that'll give us our decay rate. So then it says, after how long will the final amount be 14 pounds, right? So let's plug in the information that we have. So we want to finish with 1 pound, right? We're going to start with 14 pounds, e to the negative, the k. I'm just going to use this exact, right? So you want to do the best you can to not round it to the end. You can crush that number, but if you do and you use that result before you get to the end, you need to write out all the decimals. So either you can write out all the decimals or just leave it as a fraction. But you just don't round until the end. Otherwise, it's going to throw things off. And we're solving for t, right? We're trying to solve for t. Okay. So we have 14 times e to the power of negative kt. Okay. Only thing we don't know is t, so we can solve for that. We can solve for t. So we divide both sides by what, 14? We get 1 over 14 equals e to the power of negative natural log of 2. I don't know how that ends. Natural log of 2 over 3.8 times t, right? If we want to get that out of the exponent, we take the natural log on both sides. Take the natural log on both sides. Natural log is the inverse of exponential, so they're going to cancel each other out. And on the left, that natural log of 1 by 14 persists. It just remains. On the right, we have natural log of 2 over 3.8, the negative times t, right? So at this point, we have some number equals some other number times t. Let's do that one more time. At this point, we have some number equal to some other number times t. So if we want to solve for t, what do? We divide both sides by this number. All right, we divide both sides by this number, right? Okay. So then ultimately t is going to be natural log of 1 by 14 over negative natural log of 2 over 3.8, right? And we just crunch that number to solve for t. Okay. All right, so what I'm going to do now, try here. Let's see which one. No, that's not what I want. Come on. This one. Okay. So we're going to crunch this number. So on top, we can just say negative natural log. We got 1/14. Okay. Divided by the natural log of, okay, let's do it this way. Parentheses, natural log of 2 divided by 3.8. Okay. And after how long, right? If it takes 7 days for half of it to remain, then something slightly more than 7 is what we would anticipate, right? So 14 days. Okay, that's plausible. It could take 14 days. So we're going to say approximately, I'm just going to take it out a few extra decimals, 14 point, we can do 468. We'll just do 468 for now, days. Okay. So then we'll hop back over to Pearson and let's see how did we do. Okay, hopefully we didn't make any mistakes. And I want this one. Come on. All right. Overloading the system. Come on. Oh no. Heard it. Oh, okay, I think we're okay now. Yeah, I want this one. Okay. So there'll be 1 pound. Oh, did we lose our work? We surely did. I think we got 14. Can I pull it up again? We got 14, and these are hours. 14 point, it says to the nearest whole number. So the nearest whole number is 14 even. So after about 14 hours. Come on. The X. Okay, 14 hours. Let's try that. Whew. The hard, it's like I'm having more trouble with like just the technology over crunching the numbers. Okay. Let me see if we still have an audience. Because if we don't, let me see. Okay, cool. And that looks good. Okay, let's keep going. This is fine. Okay, it says the half-life T for a particular radioactive element is 7 minutes. Find the decay rate, right? So we just said the half-life formula is KT equals the natural log of 2. They want us to solve for the rate. So then if you just say the natural log of 2 divided by 7, that should give us the rate per minute. So, hey Siri, what's the natural log of 2 divided by 7?
The answer is approximately 0.099021.
0.099021. And I didn't get any of that. Come on. 0.099021. I think that's what she said. Hey Siri, what's half of natural log of 2?
Sending to Charles's iPhone.
Oh my goodness. You just gave me the answer a minute ago. Hey Siri, what's the natural log of 2 divided by 2? That's not even the right thing. That's not right. Hey Siri, what's the natural log of 2 divided by 7?
2 divided by 7 is about 0.2857.
Let's try this one more time. We must be in Mercury retrograde or something. Hey Siri, what's the natural log of 2 divided by 7?
The answer is approximately 0.099021.
Cool. Okay, it says then round to the nearest tenth. So 10's 100, so this is going to be 0.1. And I think oh, wait a minute. Wait, that was as a decimal, but they wanted it as a percent. Normally, when you go from percent to decimal, you move the decimal to the left 2. So we should move it to the right by 2. So this is about 10% per minute. Wait a minute. Can we undo? We had 0. Tag on it. I gotta redo it. It was 0.099021. I think that's what it was, right? So we got to convert this decimal to a percent. So we multiply by 100, so it's going to be 9.9. Man, I was about to be way off. 9.9. 9.9% per minute. Okay, I think that's fine. Let's hit enter. And I guess it's that time for my neighbor to do her exercises. So she just started. Like, this is so funny. Every class, it's like she got a schedule set to work out in the 6 o'clock hour on Mondays and Wednesdays. Okay, let's see this one. It says the decay rate K for a particular radioactive is this, where the time is measured in years. Find the half-life, right? So again, if it's just half-life, we're just using KT equals a natural log of 2. They gave us the rate. So if we want the half-life, we got to say the natural log of 2 divided by the 2.6%. Okay. Hey Siri, what's the natural log of 2 divided by 0.026?
The answer is 26.6595.
26.695. Okay, round to 1 decimal place. So 1 decimal place is going to be 0.7. Again, you got to stop me if anything isn't clear. If you don't stop me, I just keep going. All right, because I don't really know. I can only assume one of 2 things if you like stay mute. Either you get it or you don't. That's all I can. That's the only assumption that I have, right? Because I can't until I get feedback. I don't really know where you guys are. Oh man, like I don't know. And it's so bizarre. It's like I'm kind of going off my mind because we have this like really nice gym downstairs, but I'm pretty sure it's a female. Usually the females don't like to like exercise in public places, which I totally get. But I'm like, geez, man, like if you got to work out in your unit, why did you get a room on the top floor? Like, why would you do that? Somebody inevitably is going to be living below you. You know, if you want to work out in your unit, just like be considerate. But anyway. Oh, it's totally distracting. Let's go. Let's keep going. Okay, of an initial amount of 6,000 grams of lead, lead-210, how much will remain in 160 years? Lead-210 decays at a rate of this. Okay, if we're talking about exponential decay, let's get a copy of this and let's take some notes. Matter of fact, make this a little bit more legible. That'll work for now. And I ain't gonna lie, like as soon as I get off with you guys, well, actually, I got another class that I meet with. Oh, come on. I was gonna say, as soon as I get off with you guys, I'm gonna go do some gaming. I play Mobile Legends and Dokkan Battle. That's all that I play. Ooh, I think they started practicing sumo wrestling upstairs. No, come on. I think they're working on their plyometrics. I think they traded for like the Olympics or something. They're doing jumps. It's so funny. Okay. Of an initial amount of 6,000 grams, okay, how much will remain in 160 years? So we're talking about exponential decay, right? So let's go ahead and write the exponential decay formula. I like to write it in the form of like A of t equals A naught e to the negative kt. Again, we're just using a negative exponent because we're talking about exponential decay. Okay, it says the initial amount of 6,000 grams. So that means that our starting amount is 6,000 grams, right? Okay. How much will remain? So if it says how much, that means we're solving for t, right? And how much is going to remain after 160 years? So then that means that our time, no, we're not solving for t, sorry. How much, not how long. If it says how much, that means we're solving for, we want A capital A. So I'm telling you, it's people upstairs are totally distracted. Let me see, how much will remain? So we're solving for capital A of 160 years, right? And again, the time is 160 years. Do we have anything about the rate? And then it says that our decay rate percent per year, right? So our K is going to be 3.15% per year. Okay, that's fine. All right, I think we have all the components, right? We got our A naught, we got our K, we got our T, so we can get the future amount, right? So then A of 160 is going to be the 6,000 times E to the negative. Now that 3.15, we have to change the percent to a decimal, so 0.0315. And the time is 160 years. So we're just going to crunch that number. Cool, and you're still working. This website finally started remembering that I already have the ROM. Now I don't have to go put it in. I'm so grateful for that. Okay, we got 6,000 E. We got a negative 0.0315 times 160. Okay. All right. And we get, let me see. How much will remain? No. What does the question say? How much will remain? So if we start with 160 grams, 38, we get, okay. So we get approximately 38.842. Let's do it 8425. 8425 grams. Okay. So then we want this guy. So if you work properly, this one. Come on. Oh, I keep crashing my system. Oh, the whole thing shut down. Let's see. I'm coming back, guys. Let's start here. Let me start the stream. Is the stream? Oh, the stream is still going. Awesome. So let's share the screen. Start the browse. And let me turn. Oh no. Uh-oh. Wait a minute. Wait. Share the screen. Microphone is on. Let me make sure. Start the broadcast. Hopefully, it's been picking up my audio all this time. This one. Yeah, I think we're okay. Okay. All right. So now let's try to get back. Okay, we can use this. Man, they are like going in. Woo. It's like, come on. Hey, I know you can hear me. All right. Let me see. Round to one decimal place. 38.8 grams. Okay, let's go with that right here. Cool. 38, that's not an 8. 38.8. Nope. 38.8. Okay. Let's see. Cool beans. Okay, we got it. Let's see. Just go to the next question. How many more? Oh, we've only done 4. That's fine. Okay. I might do 1, maybe 2 more. It says the amount of carbon-14 present in animal bones 2 years after the animal's death is given by this, right? How old is an ivory tusk that has lost 37% of its carbon-14? Let's take some notes. We're gonna go like this. We want it from here. Come on. That works. Okay. I'm gonna take that and we right here. Oh no. Why is there another one? I don't even know. Done. I don't know why there's a second one. Get rid of that one. We're working here. Okay. Can I just insert the last image? Is that the right one? I think this is right. Okay. Let's go with this. Stomp. Okay. It says the amount of carbon-14 present in animal bones is given by this. How old? So, okay. So we're given the model, right? So that reduces a lot of confusion. So let's get a copy of the model. So we have what P of T equals P naught times e to the negative, oh my goodness. How many zeros is that? 3? 1, 2, 3. 12,097. 12,097 times T, okay? It says how old, so that means we're gonna solve for T. If it's lost 37%, right? So if we started with P, which is, if we started with 100% of P and we lost 37, if we lost 30, we would be what, at 70 plus an additional 7, so that leaves us at 63%. So that means we're gonna finish with 63% of P naught. Hopefully you can see what I did there, right? We started with 100% of P naught, now we're finishing with 63% of P naught. E to the negative 0.000, 12,097, and we're solving for T. Yeah, this is fine. So, oh my goodness. Man, thank you. All right, let's see. So we can divide both sides by what? P naught, P naught, P naught, right? So then we'll have 0.63 equals this decimal 00012,097 times T. Then we just divide. We say T equals the, sorry, nope, I skipped a step. This is still in the exponent, right? So it's e to that power. So then we need to take the natural log on both sides, right? Natural log. On the right-hand side, natural log and e cancel, and that brings it out of the exponent. So then we get some number on the left equals the thing on the right. Long story short, T equals, we're gonna have this 0.00012,097 under the natural log of 0.63. All I did was divide both sides by that decimal. When you take the natural log, again, it brings this guy out of the exponent. So then we had this left red circle equal to the right red circle. So then I divided by this number in front of T. Okay. Okay. So then if we crunch the number, we're gonna have, let's clear, we got negative natural log of 0.63 divided by 0.00012,097. Okay. Let's go like this. Let's see what was the question. It says, I don't know. How old is it? About 3,819 years old, approximately. Round to the nearest integer. So the nearest integer is going to be 19. So approximately 3,819 years old. 3,819 years old. So one thing I'm trying to tell myself to feel better is like, okay, well, at least they're doing it during like daylight hours and not like at random hours. Because sometimes it would be like 2 or 3 in the morning, and like they would be pacing back and forth nonstop. I was like, man, I hope they're okay. Yeah, I was kind of concerned. Like it felt like somebody was like really, really stressed out. But then it was stressing me out. Just that pacing was like, ugh. Okay, like this. Come on, right here. And we want this guy. Cool, that's better. Come on. Thank you. Okay, let's give it a go. We got 3819, 3819. Cool. Okay, we'll do one more. So this will be the last one. I know we're a little bit early. I'm just meeting another group at like 7. I'm usually late to that group, but it's okay. It says, how much money must you invest now at 4.4% interest compounded continuously in order to have 10,000 at the end of 6 years? Okay, this take some notes. What I'm going to do is like this. We're going to go from. I like to get a copy of the question ID just so we know where in the book it's coming from. So if you ever reference the stuff later, you know how to find it in the book. We're gonna take this and drop it. I want it on its own page. Right, this guy here. And so I was gonna go back to this game because I just like there was a character on there. So I usually play like support roles in these 505 battles. And there was this character came out. She was a free character. Her name is Florin. She was a healer. And I played her. I was like, man, this character is crap. And then so like the other day, I was pissed off. Like I was just pissed off. I was like, so I just got with the random set of group, and I made some lame excuse. I made some lame excuse to troll them. I was like, man, y'all are crap. You know what? I'm just trolling this match. I'm just gonna troll. And so I chose the worst character I could think of. And but it's funny. The funny thing is, that's how I always learn the characters. Because that's how I learned Diggy. I got tired of my teammates and these strangers playing so poorly. I just chose a random bad character, and then I actually learned how to play him. And like now, I'm like number 10 in the U.S. for this character. And so I did the same thing with this other character that I hated. But come to find out, she's even better than the first guy. I was like, oh, I really like this character now. So she's smooth. She's real sneaky. Because like you don't realize what she's doing. By the time you realize what she's doing, usually the game is over and we've won. Usually, not always, but like I say. Anyway,
Which
okay.
game?
This game is Mobile Legends Bang Bang, and there's several like knockoffs or whatever, but I play Mobile Legends Bang Bang. So my my username is what is it? It's vegan math, right? It's just I just chose something because it's all psychological, right? And it's all a bait. They see the name vegan math, they see I choose these dopey characters, and then next thing you know, I be like, we be winning, and I be getting MVP. I'm like, I don't know how I got it. Y'all be afraid. Like I'm not afraid of them. I'm messing with them. I'm just messing with them, and I just keep messing with them. It's really really funny. It's really funny when I win with these characters. But anyway, okay, let me try to wrap this one up. So how much money must you invest? Okay, so this is it says compounded continuously, right? Let me think about something. So we're going to try something a little bit different. Now, normally what we do, we use the PERT formula, right? So the future amount is going to be PE to the RT. So this is talking about like giving some present amount if you want the future amount, right? But say we know what the future amount is, we need to know how much do we need to start with to achieve our goal. Then you can actually switch this around. This is using exponential growth. We can actually use exponential K to get to kind of work backwards, basically, right? So we can either do that one, or I'm going to try this analogous one. If we want the present amount, that's going to be the future amount times e to the negative RT, right? I think this will work, right? So now let's try the purple. Okay. So we're trying to find the present amount. We want to finish with $10,000. I don't know if you remember, speaking of $10,000, I don't know if you remember the other day or not, me mentioning like these cryptocurrencies. Like, so Shiba Inu it's been dropping. Like when I got into Shiba Inu, like first of all, the price of each coin for Shiba Inu when I got in was like fractions of pennies. Like it was like penny stocks, right? So you can get in for like $10 and have like 1,000,000 stocks, right? But it has a value of $10. But the reason I got it was because it was so cheap. And like again, my former student, she sent it to me. She was like, "Yo, you might want to get this. It's projected to go to $1 by the end of last year." Obviously, it did not go to $1. But today, like I think I had invested maybe a total of $200 in it, and it got all the way down to I had lost like $100. But I had already resolved. Like I told myself, I was like, "Well, whatever I put into this, I'm okay if I lose it. So I'm not gonna cash out until it's something ridiculous, right?" So today it's been like going crazy. Like I recovered, like I lost 100, and today I got $50 of it back. And last time I checked it, it was still growing. So I'm like, oh, bet, like, oh, it's about to pop off. And like my girl was saying that like basically it's all based on Bitcoin. Whatever Bitcoin does, the other coins kind of like follow suit. So like if Bitcoin is going up, the other ones go up. If Bitcoin is going down, the others do something similar. Again, I'm no financial guru. You have to do your own research. But honestly, you can like teach yourself. Like if you really want to know about it, if you just start searching on YouTube and stuff like that, there's a lot of people that like talk about it and it's free information. I don't know if it's the best information, but it's free and you can at least start. And you can start with like $5 or $10 on like Cash App and trade like Bitcoin and different coins. I just downloaded what is this one called? I think it's called like crypto.com or whatever. Just let me know. But again, I'm no financial anything. I'm just a mathematician that's just playing around with crypto. And I'm just also saying, hey, today it went up by like 50%. Like it was crazy. Like 3 or 4 of them went up. So like if you had $100 in there, you would have earned $50 today. Just having it in that account. But again, that's not really my place. I'm just a mathematician just talking random stuff. I'm no financial anything. You definitely want to, if you decide to walk that path, you want to get what is it called? A consultant, an actual person that does this regularly. I'm just saying today it started like spiking, and it's not too late for anybody to like take advantage of it. But I think that's something that like I don't know how many of you guys are business majors or not. I know this is calculus for business, but it's definitely something you want to look into, like because I can go on and on about crypto and all this, but let's try to wrap this one up. So if we plug in, right? So we want the present amount, we want a future amount of 10,000, e to the negative, let's see if this works, the rate. How much money? At 4.4%. So then we got to do that 4.4% as a decimal, so 0.044 at the end of 6 years, right? I think this will work. So then if this is how much we should invest now, it should be something less than 10,000. If we're talking 6 years, maybe like 6 or 7,000, something like that. Something like that. Let's crunch this number and see what happens. I want this one. Okay. And like, I mean, it's a whole saga. Cause like all you need, once you have like one success in that round, your life is transformed, right? And I feel like it don't even take that much to get there. You just gotta have something in the pot and just forget about it. And then one day when you come back and check it, you're like, wait a minute, But if you don't have anything in the pot, you're guaranteed to earn zero. So that's how I feel about it. But only use money that you're willing to lose. Like if you're depending on it, then you got it wrong because you're gonna stress yourself out. But it's all psychological. Okay, if we crunch this number, negative 0.044, and the only reason I started studying, one of my former students from Morehouse was teaching me about like Forex and all this stuff. We kind of went back and forth for a little while. I put it down and pick it back up, and it's interesting. You don't really have to do anything. You just got to learn the system and keep trying until you get it. And it's all philosophy and all this other kind of stuff. See, about 7,600. Okay. Let's see, how do we do? So we're saying approximately we need to start with, it says the nearest cent, so 74. 76, 79, 74. Okay, let's see how do we do, and we'll wrap it up. And I'm king. I told you I'm the king of procrastination. I love going on tangents, so it's okay. We're wrapping up class anyway. this one. That's fine. Just on the left. Okay. All right. Right here. 76, 79, 74. 76, 79, 74. Okay. They're set. Cross our fingers. Makes sense. We're good to go. It don't make dollars if it don't make sense, right? Okay. And that brings us to a good stopping point. So the main highlights from today. So our exam one will be available 7 days from today, right? So next Monday at the start of class, that's when exam one will become available, and you can earn up to 100% for 7 days. So it'll become available next Monday, and then the following Monday it'll be due at the start of class. But again, you can work on it past that due date, but then there's a 10% late penalty. And again, we get unlimited attempts on all assignments, and I think the system is set to take your highest score. Are there any questions that we can share for our YouTube family before we sign out? Okay. If there aren't any questions, if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. All right. Take care. I'll see you on Wednesday. Peace. All right. Let's go here. Let me stop the stream.